So in this example, we're going to do a class that's going to have a friend class. So we're going to use friend not just for saying functions are friends, but actually saying functions are classes. And so what we're going to do here is just make a simple linked list type class, and it's going to be built up of these word nodes. So here's our complete word node class. It has two private members. It has a string member where we're going to actually store the word at that node, and then we'll have a pointer to the next node. And our constructor will set the word to whatever string was passed in, and then set the next pointer to null pointer, because when we initially create that node, it doesn't have a next. Now you may remember if you took 205 from me, we did an example of a linked list where we had a private class, and that was a private node class that then the linked list used that node. And the concept is, I guess, somewhat similar to what we'll do here. And our word list, or our word list class, I should say, we'll keep track of the size, and then we're going to have a pointer to the first and last word nodes in our list. And then we'll have a constructor which won't take any parameters because you'll instantiate that list as an empty list initially. And actually for this, I believe we can just do a construct initializer here. So we'll just say what the values are. And that helps us save a little bit of space just to make sure that this compiles. I'm not sure I've ever actually done that before, but we'll give it a try. So that's good. Yeah, nice. So that's some code that I'm able to eliminate. That's always a good thing. Okay, very good. So there's my constructor. And then I also have a destructor, which is going to be a little more complicated. Because I'm going to have to go through the list and free each node that's in the list. So notice there's no new in my constructor, but as this object gets used, or as an object of this class will get used, we're going to be calling new a lot to create new nodes. And so we have to have a destructor that, even though the constructor doesn't allocate memory, or the constructor doesn't allocate memory, the destructor still has to clean up memory because it was allocated elsewhere. And that should be a tilde, not a exclamation point. So now I'm going to have another pointer I'm going to use. And while there's something in the list, and again, if you remember back from any of the linked lists that you've seen either in Java or C, this is a pretty straightforward traversal. So we're going to set cur equal to cur.next. We're going to delete the pointer, and then we're going to set pointer to null pointer. So we'll do that, and then once this loop is complete, we've deleted all the memory allocated. So we'll go ahead and set cur equal to null pointer. Pointer is already equal to null pointer because we did it here. And then first will be null pointer, and last as well. So that's our destructor. It's a little more complicated than the constructor in this case, just because we have to do some additional work. So what is this for? Looks like that's an extraneous thing there. So there's our destructor. We'll add strings to the front, and we'll go ahead and add them to the rear as well. And then we'll also have an isEmpty method, and that's going to return whether or not the size is equal to 0. So if you haven't seen this kind of construct before, this equality check returns a Boolean. And so since it returns a Boolean, I can return that value here. So I'm not going to spend too much time on the add to front and add to rear functions because I don't think they're necessarily that interesting for what we're trying to do here. So let's compile our code as it stands right now. This is a WordNode pointer, and so when I try to access the next, notice that's private. And you may say, well, make it protected. Well, the problem is if I make it protected, it's still, there's no inheritance relationship here, so that's not going to help either. You can imagine, I don't really want to have a bunch of accessors here or mutators to work with this word node. That would get tiresome. And the reality is, no one ever wants to make a word node, right? A word node only even makes sense in context of a word list. So what I'm going to do is I'm going to say that I have a friend class, not a method, a friend class word list. So now when I compile, notice it's happy. So now I can actually access the word node members from inside my word list methods. So let's go ahead and implement those. So here's add to front. We have a string as a parameter. We create a new node. Then we set that new node's next reference to the first because again, we have some list. We've created a new node. That new node is going to point to the old list. And then our first now will refer to that new word node that we allocated here. Okay, again, this should be familiar to you if you recall from your Java classes. To add it to the rear, we're going to first off check to see if the list is empty. If it is, then we're going to add it to the front. And then otherwise, we go to the last, we set last next equal to the new node that we just allocated. We set last equal to that and we increment the size. And actually that should work. So we handle the case where there's only the list is empty here. It's going to just always add to front. So if we ever do this code, the list is guaranteed not to be empty. So yeah, I think that's going to be good. So let's test our code by just running a few tests. So I'll make a word list and I'm going to add the string hello. I'm going to add to rear world. Then I'm going to add to rear goodbye. And then I'll add to front CSC 220. So let's compile. Word list was not declared in this scope. Line 73. Oh, I said world list. So let's compile again. And let's run. Yeah. No crashes, but it did actually do some work there because we did all these add. Now what we would really like to do, if you'll recall, is do something like this. And if you'll remember from a few videos ago, that means we need to overload the stream injection operator. So here's the error we get. There's no match for operator. So let's create an overloaded operator. So we're going to turn a reference to an O stream. The operator is the stream injection operator. It takes an output stream as a parameter and a constant word list reference. And we're going to find the first element of that in that list. And then while, and I believe this should work. I don't think we have to check that it's the null pointer. I think the null pointer will evaluate to false. Just to keep that clean, it will be null pointer at the end. So we'll just say while current. And then we'll inject into the stream the current word and a space. And we'll say current is equal to current.next or arrow next, since we're using a pointer. And then once we've done with all this, we can return the stream. So we're injecting each individual word in the list and then going to the next word node in the list to get the next string. Okay, so let's compile. And you'll notice I got some errors. On line 70, we have a private error. First is private. Okay, so we know how to fix that. What we're going to want to do is make sure that this is a friend in our WordList class. And notice this is not in the WordList class itself. This is a method that's outside the WordList class. So I'm going to say it's a friend. There's the references and so forth. And then this is just a forward declaration essentially. This is just a declaration, so I can put a semicolon at the end. Okay, so that's good. Let's compile again. Still some errors. Oops, WordNode is private. So if I go back to my function, notice here I'm getting an element from WordList, but here I'm getting an element from WordNode, and that's a private element. So what I need to do is make that method a friend in WordNode as well as WordList. So it's the same method, but it's a friend of both WordList and WordNode. So now when I compile, we're almost there. Looks like I spelled stream out a couple times. Yep, so this should just be strm. So I'm not sure why we're still getting an error there. WordList does not name a type. So here, what I can say is const class to say, hey, this is a class. And now to compile, because even though it doesn't know what this word list is, it knows that it's a class reference, and that's sufficient for it to say, okay, fine, I'm sure that when you call this, I'll know what that is. So now if I run this, we get exactly what we would expect. Okay, so this isn't really intended to be a tutorial on linked lists. The point is just to show you how friends work. And so hopefully that makes sense. We have friends that are classes, we have friends that are operators or other methods, and a friend lets you have access to the private members. Now, just like with any other friendship, you want to be careful because you want to make sure that you're careful who your friends are. Your friends have full access to all of your private members. So think of it as, would you give your friend access to your bank account or something like that? Maybe you would, but it's certainly something that you would be careful of, and you wouldn't say, hey, all my friends get access to all this. You want to be careful to think about which methods and classes you want to designate as friends. And the thing to keep in mind that's nice is, even though, yes, this breaks encapsulation from a pure object-oriented standpoint, this is bad, you still get the ability to control it yourself. So someone else can't say they're my friend. Some other class or function can't say, oh yeah, we're friends with that class, so I have full access to everything they have. No, that class has to say that they're your friend before you can actually take advantage of that relationship.